Hello everyone. This video is on the Knewton Alta assignment, section 3.2, part 3, called Graph Piecewise Functions. Alright, so in this video I'm going to go over a preview version of this particular assignment. Please understand that the questions I'm seeing in this video may not be the same questions that you see when you work on the assignment yourself, but the objectives are the same, so the questions should be similar enough to where watching me do a few of them here will help you in some way when you're working on the assignment yourself. Alright, so the assignment page here, you have the title, you got your mastery bar, the objectives. It looks like there's only the one objective here. That's nice, should be quick. Underneath the current objective, there should be a question related to that. And beneath each question, there should be a feedback button where you can send feedback to Knewton. You will not have the instructor cheat button. That's for instructors only. You will have the more instruction button. If you're ever struggling with a topic, try clicking on the more instruction button. It'll take you to a page with some reading or some videos to watch, and then you'll be given questions related to that instruction, and you can get through the assignment that way if you wish. Alright, so this first, the only objective, is graph piecewise-defined functions. Alright, graph piecewise-defined functions. So they're saying here, which of the following piecewise functions is represented in the graph below? Alright, so we're given a graph with three pieces here. There's breaks in the graph, and if you zoom in, you could see it probably from here too. That there's a solid point here, open point here, solid point here, open point there. Right? So let me just show you. Right? Let me just pick one of these. I'll take this first one, and I'll write it out. And I'll show you how to graph these things by hand. Alright. But then we'll actually go into the actual graph and write equations for these are pieces of lines, right? See, these are just straight segments. And you should know how to draw, write equations for lines. So you should be able to write the equation for each of these pieces. Alright, but let me just, I'll just write out this first one and show you what you would have to do to graph a piecewise defined function by hand. Right. So that first option is the following. We have f of x equals, and then we have negative x if x is less than or equal to negative 3, x plus 2 if x is between negative 3 and 0, not including negative 3 but including 0, and negative 1/2 x plus 3 if x is greater than 0. So remember, you were introduced to piecewise functions, piecewise defined functions in section 3.2 part 2. So remember, the input is x, the output is f of x, but the way you calculate the output is one of these three ways, but you can only choose one. Right, the way you calculate the output depends on how the input looks, right? These are the conditions that the input has to meet in order to use that particular formula to calculate the output. All right, so when making a graph here, x, y, I like to point out, what numbers show up in these conditions over here on the x-axis. So here's negative 1, 2, negative 3 shows up in these conditions, and so does 0. Right, so for x less than or equal to negative 3, to the left of negative 3, the graph's going to be a piece of this y equals negative x. And from negative 3 to 0, right, the graph's going to be a piece of y equals x plus 2. And to the right of 0, the graph's going to be a piece of y equals negative 1/2 x plus 3. And I'll put in some more values here, negative 4, negative 5, negative 6, 1, 2, 3, and so on. All right, so I'm going to do one piece at a time. So first I'll start with this top piece. X is less than or equal to negative 3. So if I plug in values there, what's f of negative 3? It would just be the opposite of negative 3. It should be positive 3, right? I'm just using this top rule. So negative 3, 3 will be on the graph. And it'll be a solid point, right? Because negative 3 is actually part of this piece, right? It's for values of x less than or equal to negative 3. So I put a solid point there, and then I plug in, say, negative 4, and get positive 4, right? It's the opposite of x. Negative 4, 4 would be on the graph. And, negative 5, 5, negative 5, 6, right? We're on the graph y equals negative x, right, which is a line with a slope of negative 1, but only to the left of negative 3. So there's that piece of the graph, right? But that's it. It stops here at negative 3, 3. Because after negative 3, right, between negative 3 and 0, we're drawing a piece of this graph, y equals x plus 2. So that's for the top piece. Now if you want, you can plug in negative 3, even though it's not there, right? X is greater than negative 3, and there's going to be a hole. Right, there's going to be a hole. F of negative 3 in the second piece, I shouldn't say f of negative 3. I'll just tell you what the hole is. Negative 3, if you plugged in negative 3 here to the second rule, negative 3 plus 2 is negative 1. Negative 3, negative 1, that's where there's going to be an open point on the graph. See, an empty point, a hole. And the reason for that is because negative 3 doesn't satisfy this condition. I just wanted to point out where the piece starts. Now at the other end, 0, that's actually part of it. X is less than or equal to 0. So we could plug in 0, get f of 0 would be 0 plus 2. Right, so I have 0, 2. That is a solid point. Right, so if it belongs to the piece, solid point. If it doesn't belong to the piece, it's at one of the other ends, open point. And the graph is just a line, right? Y equals x plus 2, but only a piece of it. You'd have negative 1, 1, right, is on here. Negative 2, 0 should be on here. Right? If you plug in values between negative 3 and 0, you just add 2 to them. Negative 1, 1, negative 2, 0, negative 1.5, and then you get 1/2, whatever. But you're just getting a piece of the line y equals x plus 2, not the entire thing. Starting at this hole, again, there's a hole there. One more time, there's a hole here, an open point, because negative 3 isn't actually part of this piece. Right? It doesn't satisfy this condition. But there's a solid point at x equals 0 because x equals 0 does satisfy this piece. Right? It does belong. All right, then to the right of 0, again, just to say where the piece starts, I'll plug 0 in, and there's going to be another hole, another open point, because this is for x values greater than 0, not equal to 0. But just to see where the piece starts, so I'm going to plug 0 in, and you get 3. 0, 3. So 0, 3, there's going to be a hole, an open point, and that's where this third graph will start, the third piece of the graph. And then you plug in, say, if I plugged in 2, right, f of 2 would be 2, right, negative 1 plus 3. So 2, 2 is solid. And then it's just a piece of a line. It's just this line with a slope of negative 1/2, starting at this hole at 0, 3, right, going down like that. And there you go. All right, there's a graph of each piece. So you just got to pay attention to what inputs belong where. The graph of y equals negative x, but only up until negative 3. and a solid point at negative 3 because negative 3 belongs. Right? Y equals x plus 2 from negative 3 to 0. You have an open point at negative 3 because negative 3 doesn't belong, and you have a solid point at 0 because 0 does belong. Right? And then y equals negative 1/2 x plus 3, but only to the right of 0, and at 0 you'd have a hole, or an open point, because 0 doesn't belong. Right? You just got to pay attention to what belongs to the inputs, what doesn't belong to the inputs for certain pieces. All right, now does this match the graph we were given? Let's see. Well, I got this slope of negative 1 line, and you got negative 3, 3 is solid, y equals negative x. You got negative 3, negative 1 is open up to 0, 2, which is closed, a solid point in a straight line there. That looks, and then you have an open point at 0, 3, and then it goes, slope of negative 1/2 down here. Right? You got 2, 2. This is actually this first option. Lucky us. We were very fortunate that that was the first option. All right, now let me show you how to also graph this stuff on a calculator, the free online graphing calculator at desmos.com. Now you have to unfortunately draw one piece at a time. All right, so I'm at desmos.com here, and just go y equals each time. Right, y equals, the first piece was negative x, but not the entire thing. All right, after y equals negative x, you're going to go braces, right, curly braces, and then put the condition x is less than or equal to negative 3, and then close the braces. And then you see here it's just the graph of y equals negative x up to the point negative 3, 3, and you see it's solid, right? Because negative 3 is actually part of that piece. All right, then for the second slot, I'll put the second piece, y equals x plus 2. Again, don't leave it this way, because if I leave it this way, it's not a function, right? It doesn't pass the vertical line test. After y equals x plus 2, I put curly braces, and then the condition, negative 3 is less than x, and x is less than or equal to 0, and close it, right? And then you see just that piece, you see 0, 2 solid, but at the other end it's an open point. See, negative 3 undefined. At negative 3, negative 1 there's a hole, like I said, right? Because negative 3 is not actually part of this piece. You still plug it in just to see where the hole is, but it's not part of the piece. Right? And I'll graph the third piece, right? Y equals, it was negative 1/2 x plus 3. Again, don't leave the whole line in there because it's not a function anymore. It doesn't pass the vertical line test. Curly braces, and then I put the last condition, x is greater than 0. And there's your third piece, right? And once again, you see at 0 there's a hole. It's 0 undefined at the point 0, 3. And the reason it's a hole, an open point, is because 0 is not a part of that piece. It's only for values x greater than 0, right? And then you get all these other points here. Right. And if you want, you can change them all to be the same color, because they are technically part of the same graph here. And there we go. All right, now they're all blue. Right. And this looks exactly like what we had. Right. So we got lucky for this first one. Right. The graph of this first function is the graph that they gave us. All right. And again, after every time you submit an answer, right, you'll be told if you're right or wrong. And there should be some sort of answer explanation. Please read through these, whether you're right or wrong, just to make sure you know why you got something right or why you got something wrong, so maybe you can learn from your mistakes for the future. All right. And then every question should be in this objective. All right. So here, if you look at this, now this time, you got a linear function only up until negative 2 though, but not including negative 2. See how there's an open point there? It's kind of tiny, but it's open. So I have some linear function with a positive slope. Looks like a slope of positive 1. So I think it'd be y equals x plus 2, because you see if you continue that on, it would hit the y-axis at 2. It has a slope of 1, y-intercept of 2. So it looks like y equals x plus 2, but just until just for values of x less than negative 2. So if I look at these options, the only one that matches that is the fourth one. Right? The other ones have y equals 3, y equals negative x cubed, y equals 3 for x less than negative 2. This is the only one with a linear function, y equals x plus 2. And then you have y equals negative x cubed, right? Let's say this cubic function here from x, equals negative 2. There's a solid point up until x is less than, not equal to 1. So between negative 2 and 1, including negative 2, but not including 1 because there's an open point. And then y equals 3, just a horizontal line from 1 onward, so x greater than or equal to 1 because there's a solid point, right? 1 is included. So that all matches this last piece here. And if you want to graph this on Desmos, you can as well. Right, I showed you how, just to verify. Yeah, so that's the only one that matches. Great. And again, please read through the answer explanations. I think we got all this. All right, so here, horizontal line, just y equals 1 for values of x less than negative 2, but not equal to negative 2, right? Because you got a hole. So it's either option 1, 2, or 3. Right, they all have y equals 1 for x less than negative 2. Then the next piece here is a line with a slope of 2, right, rise 2, run 1. It has a slope of 2 and a y-intercept of negative 3. So y equals 2x minus 3. Remember slope-intercept form? Y equals 2x minus 3 from x equals negative 2 to x equals 1. But, including negative 2, there's a solid point, but not including 1. Right, there's an open point. So for x values between negative 2 and 1, including negative 2 but not including 1, y equals 2x minus 3. So that's only the second option here, and then the last one, make sure it matches. It's a line with a slope of negative 1 from x is greater than or equal to 1. Yeah, that's the only one that works for all three pieces is this second option. And again, it should be this easy, I feel. Right, I feel. And if you want to go through and graph each one of these by hand, graph them all on Desmos and see which one matches the one you're given, be my guest. It'll take a little longer, but that's a way to do it too. All right, then the final one here. So, this time you're given the function and asked to say which graph it matches. All right, so this one I'll draw out and graph by hand. All right, so this is the function we're given. Again, I'll make the xy plane here. Now, looking at the conditions, the number negative 2 is showing up, so I'll highlight that. There's negative 2. And then I'll graph the top piece first for values of x less than negative 2. So negative 2, negative 3, negative 4, and so on. All right. Now, notice it's for values less than negative 2. So if I plug in negative 2, I'm going to get a hole. You're going to get an open point at negative 2, and then negative 2 plus 1 is negative 1, right? So negative 2, negative 1, there is an open point. All right, so that's going to be where this piece ends. Now for actual values of the function, plug in values less than negative 2. F of negative 3 would be negative 2. Right, so negative 3, negative 2 is a point on the graph, solid. And really you just have y equals x plus 1. Right? It's just a line with a slope of 1, but it stops at that hole. Alright, so there's y equals x plus 1, but only a piece of it, right? It stops at the hole negative 2, negative 1. Alright, then for the next piece, we can actually plug in negative 2. So I can figure out what is f of negative 2 now. Now plugging in negative 2, that'd be 4 minus 3, that's 1. Negative 2, 1, and that would be a solid point. Alright, that actually belongs to that piece. And then if I plug in, say, 0, you'll get 0, negative 3, right? This is a line with a slope of negative 2. It's y equals negative 2x minus 3. So as a slope of negative 2 crosses the y-axis at negative 3. But it's only a piece of it, though. Right? It's only the piece of it that starts at this hole. And that's it. I have graphed both pieces. There's our function. And again, it passes the vertical line test, right? I know it doesn't look like it here, but remember that hole is not really there. If I draw a vertical line at negative 2, it's only going to hit the graph at that one point. Okay, and once again I can go to Desmos and show you a better picture. This is, I mean, these are lines. This wasn't a bad picture I drew. But if I go to that Desmos site, we can graph each piece. Again, the only unfortunate thing is you have to graph each piece separately. So the first piece was y equals x plus 1. Again, not the whole thing. I put in braces, x is less than negative 2. Close the braces, right? There's that first piece. Right, it's the line y equals x plus 1, but only up until this hole at negative 2, right? Negative 2, negative 1, but you see it's negative 2 undefined. But you see it's an empty point, an open point there. Right, and then the second piece was y equals, negative 2x minus 3. But again, not the whole thing. If I leave it that way, it's not a function. Doesn't pass the vertical line test. I got to put the braces. And then the condition, x is greater than or equal to negative 2. Close the braces, and there you go. And if you want to change them to be the same color, go ahead. But see, there's a solid point up here, negative 2, 1. All right, solid point. And then every other point down here is on here as well, right? There's 0, negative 3, as we said on my graph, right? So there's a graph of this piecewise defined function, and we're asked to match, which graph here matches. So not that one, not that one, that one. That one has a hole at negative 2, negative 1. Y equals, is a line with a slope of positive 1 over here. Then you have negative 2, positive 1 is a solid point. And then you have a line that goes through point 0, negative 3, right? It has a slope of negative 2. This one's the one that matches the one I graphed. Wonderful. Alright, so again, I'm hoping that you understand, with these piecewise defined functions, you should be graphing them, one piece at a time, one level at a time. I would recommend that highly. And pay attention to when you have less than or greater than or equal to. Is there a half equal sign or not? Right, if the equal sign's there, that means there's going to be a solid point at that value. If the equal sign's not there, there's going to be an open point at that value, a hole. And just yeah, and again, I hope you saw how I graphed them on Desmos as well, one piece at a time, because that's obviously a very useful tool if you're having a trouble doing it by hand. You can always go to Desmos and check it out there. Right. All right, and that should be it for this preview version of this assignment. As I said at the top of the video, right, please understand that the questions I saw here are not necessarily going to be the questions that you see when you work on the assignment yourself, but the objective is the same, so the types of questions you see will be similar to what I saw, and the way you go about doing them. Now I know I did the first one pretty more involved, and then I kind of rushed through the other two, but you should be able to, if it's multiple choice like this, you should be able to look at some pieces and figure out which choice matches pretty easily. If you know what certain graphs look like, you should know what graphs of lines and parabolas and cubics and square roots and all those toolkit functions from this book. You should know what those look like already. And I'm also hoping that seeing me do this here helps you learn how to graph them in Desmos and helps you in some way when you're asked to graph a piecewise defined function on your own. All right, and thank you very much for watching.